cytoplasm process. The 10 or so enzymes in glycolysis are just free-floating globular proteins floating around in the cytoplasm of the main part of the cell. Here's the next reaction, the overall reaction. One glucose molecule goes to two pyruvate molecules. Of course, 6 carbons in glucose. We get 2 copies of this 3-carbon carboxylic acid. You can see right away that there's evidence of some oxidation. We start with an aldehyde group and we end up with a carboxylic acid. So that's a little bit of oxidation we know it's happening right away, besides cutting it in half. A universal pathway. So while not everybody does the Krebs cycle and respiration, only aerobic ones do, all organisms, aerobic plus anaerobic, do this part. This is considered one of the first metabolic pathways to evolve. It developed before there was even any oxygen in the atmosphere. So it goes way back. It's kind of a primitive pathway. For all the many steps of glycolysis, you only clean 2 ATPs per glucose cell. So it's inefficient in that sense. You're not getting a bunch of energy returned from this breakdown. But yet it's something that we retain. It hasn't been supplanted over the eons with a better version. We use it still. All of our glucose flows through that. It's kind of a setup to generate that product pyruvate. That's a setup for the next step, the aerobic part, where we do complete oxidation and get most of the ATP. So it's a necessary precursor to the TCA cycle. Also, in addition to that role, glycolysis sometimes is all we got. Sometimes it's our standalone energy supply. And that happens when a cell gets low on oxygen. To do the TCA cycle and the electron transport chain, you need oxygen. If you don't have oxygen, you're just stuck with this guy, just with glycolysis. And that happens even with humans sometimes. That, at least some of our tissues start to go anaerobic. And under those conditions, you see glycolysis ramp up to very high levels. Okay, 3 general things happen during glycolysis. One of the most obvious is you're generating products, 2 pyruvate molecules, 3 carbons each from the 1 carbon. So you're chopping it in half. The other thing that happens is we phosphorylate a couple of ADPs, like 2 ATPs, by a process that goes by the name of substrate level phosphorylation. We'll distinguish this later on with another way of making ATP called oxidative phosphorylation. So those are the 2 ways. In glycolysis, this is all we have. In this, it's called substrate level because you have very high energy level substrates that are intermediates in glycolytic pathways that donate a phosphate to ADP directly. Okay, so we make a couple ATP. The third thing that happens is we do some oxidation. Glyceraldehyde 3-phosphate is oxidized, donating a pair of electrons to this carrier, NAD8, that last time, to make a couple NADH. So a little bit of oxidation, a little bit of phosphorylation, and chopping the molecule into 2. Formerly, people had looked at the glycolytic pathway, and here it is in all its glory, as a 2-stage process, color-coded here for you.